Hello you guys, today we're going to talk about direct variation. The table below shows a relationship between the input signal power of Eric's amplifier in watts and the resulting output sound intensity in watts per square meter. So if he inputs 2 watts, the output on the sound intensity would be 1.5 watts per minute square, right? If he inputs 12 power in watts, then his output would be 9 watts per meter square. Okay? So does this situation represent a proportional relationship? We will find out. How do we find out? We would like to do the y over x, okay? That's what we want to do. We want to do y over x values. Okay, and we're going to do 1.5 divided by 2, 3.75 divided by 5, and then 9 divided by 12. Okay, so 9 divided by 12 can be simplified as 3/4, which is the equivalent of 0.75, right? 1.5 divided by 2 would give you 0.75, and 3.75 divided by 5 would give you 0.75. These numbers are all the same, right? And all we did was to divide y divided by x. That's all we did, right? So if they're all the same, that means that this is a k value, which means that the situation does represent a proportional relationship, because remember the proportional relationship has a y equals kx equation, right? Standard equation. So the way you would explain this and say that it is in fact a proportional relationship is by saying that the ratios, right, of y divided by x are all the same. Okay? If the relationship is proportional, what is the constant of proportionality, or k value? Well, I talked about it on the previous slide. The k value is going to be your y over x values, which in this case would be 0.75, right? That is your k value. Constant of proportionality or k value, these two are the same thing. Okay, they are the same value, which is 0.75. If we want to write an equation that represents this relationship, the standard format would be y equals kx, where all you need to do is replace that k, substitute that k with that value that you found by dividing your y over x values. In this case would be y equals 0.75x, and that would be your equation. We are going to graph this relationship, okay, and we're going to notice that this proportional relationship, okay, which is also known as direct variation, okay, is linear because we have a k value, right? So I will start with 2 and 1.5 right about here. 5 and 3/4, so it'll be 3 and then 3/4, so it'll be right about there. 12 and 9, so 2, 4, 6, 8, 9. Okay, and I'm going to try that line. It's not that straight. Okay, so what that's showing you is that it's a linear equation, even though my line is not as straight. But it is a proportional relationship. It goes through the origin. How do we know it goes through the origin? Think about it in terms of that scenario. If Eric does not input any power, right, into that amplifier, he's not going to have any sound coming out, right? So then he would have 0 power in watts. Therefore, the output of this is going to be 0 sound, right? Now, the situation represents also a direct variation. known as the proportional relationship, because y varies directly with x, because y over x are the same for every row on the table. All of these, and you can pause this video and get your calculator, all of those numbers are going to simplify to 0.75. Okay, so the equation of the direct variation where y varies directly with x, right, is y equals kx, where y divided by x will give you your k. This is also known as a constant of proportionality or constant of variation. So the graph of a direct variation where y varies directly with x is a straight line that passes through the origin, which is 0, 0. Remember, we talked about if he has 0 watts, he's going to get 0 sound. The table below shows the widths and lengths of a United States flags. Determine whether the data sets shows a direct variation where y varies directly with x. If so, write an equation and describe the relationship. So if we grab all the x and y values of that table, right, for us to know that it's a direct variation, they will all have to equal to the same value. So if I have 0.95, which is my first y, divided by my first x, I'm going to grab my third one, and then I'm going to get my last one. I would like for you to pause the video right now and get your calculator and see if you come up with the same number I did. Okay, so 0.95 divided by 5 would give you 1.9. 3.8 divided by 2 will give you 1.9. 45.6 divided by 24 is 1.9. If all these numbers are the same value, then you have a k value, okay? Because remember, the y divided by x gives you your k. And it shows a direct variation because all of the numbers are the same value. So then you can say that the equation would be y equals 1.9, which is our k value, right? X. This right here would be your equation. The minimum amount of time it takes a diver to ascend, going up, safely to the surface of the water varies directly, right, with the depth of the diver. So depending how deep he is in the water, that's how long it takes him to come up to the surface, right? So we are going to grab only the points that show dots on it, just to be a little bit more consistent. So 60 and 2. We're going to grab, it's going by 6, 120. So I'm going to get the next point right here, which is 180 and 6. And then the last one would be 280. Well, I'm going to leave it at that. I only need 2 points, mainly. Okay, so if I do 2 divided by 60, right, I'm going to have to simplify this fraction because I don't want to get a decimal. It's going to give me a repeating decimal. So what I'm going to do is I'm going to find the multiples, right? We have a common of 2, so 130. That's how you simplify to 130, right? The next one will be 6 and 180. These are multiples of 6, so I can say 6 divided by 6 gives you 1. 180 divided by 6 gives you 30. So they are the same value. Therefore, that is your k value. And your process, you're going to have kx, so k times x. So the k value is 130 of 60, 130 or 1/30th of 180, right? So now they want us to find out, or they want us to predict the amount of time it takes to ascend safely from a depth of 450 feet. If you notice, feet is your X value, so we're going to place feet here, right? We're going to use the same K value to find out our Y. So Y equals 1/30th X, which in this case would be 1/30 times 450. We'll come up with 450 divided by 30. And I'm doing this because, it's a video, but you can do it in your calculator. And it would give you 15. So it would take him 15 minutes to safely ascend from a depth of 450 feet. Okay, so your equation would be Y equals 1/30th X. How does the graph verify that this is a direct variation? Okay, so we have to think about how does the graph show us that is a direct variation? Well, the graph is going to go through 0, 0, right? So we can say that it goes through the origin. Okay. How does the table verify that this is a direct variation? Well, Y over X values, right, simplified, are the same value. Okay. How does the equation verify that this is a direct variation? Well, the equation is in a format of Y equals Kx, right? Where K takes you back to the table, which is the Y over X values being all the same, simplified to all the same value. If you would like to take the notes on this slide, go ahead and pause the video and take your notes on a paper. This will help you.